So welcome to our main module for creating a PowerShell script. And in this module, we're going to cover the basics. So what is a basic PowerShell script, some of the best practices, and how it can actually interact with the users of the script. We talked about the pipeline before, and we're going to carry on using that within our scripts. Now, before I actually start looking at a script, you're going to see some regions. If you downloaded the sample file for this course, you'll actually see there's these hash region, and then some kind of title, then code within it, and then an end region. This is only for use within the scripting editors, the integrated scripting environment or VS Code. It does nothing to the actual code itself. Remember, the hash is a comment. This is just therefore a special type of comment that the scripting environments understand. And in this case, will kind of let me fold the code. So if I was to jump over, let's go to our project, and I'll open up the sample file. You'll actually see, hey, I start off with region module 1. And what I can do is, you notice there's a little sign next to it. If I click that, well, it collapses module 1. I can collapse module 2, collapse module 3, and then get to maybe the ones we care about. So regions can be nice in my code for if I've got these certain sections, I might want to be able to jump around pretty easy, maybe even search on it. I could search for hash region module 3, or this function, for example. So they're just there for the scripting environment. They do nothing to the actual execution. It's a hash, so it's a comment. It's just there to let me kind of fold that code and maybe navigate a little bit easier, have a little bit of a cleaner environment. Now, we're not going to cover signing scripts in detail yet. However, when we start to dive into using scripts, there can be a challenge because there is a policy about execution of scripts. And we can see this with get execution policy. Now, by default, it used to be it was restricted. I couldn't run any scripts. So I could use set execution policy, and I could change this. I could change it to remote signed, i.e. it has to be a trusted publisher for an external script. If I downloaded this from the internet, it would have to be signed and signed by something that was trusted by me. It could be all signed. So every script, even my own ones to run on my box, I would have to sign them. Or unrestricted. I can run anything, and that's generally not recommended. Now for our testing, we're going to set it to remote signed, which, as of Windows Server 2012 R2 and above, actually became the default anyway, instead of restricted. But we can go and check that. Now remember, I have to be elevated. So I was to jump over to my environment. If I was going to use my PowerShell 6, this is where I would kind of right click, and I want to run as administrator. If my window is not open and I right click, I'm still going to see that run as administrator option. So I'm going to run it as administrator, doing the user AC check. And then from here, I could do get execution policy. And you see mine is remote signed. So I'm good to go. But I could also do set execution policy. And my execution policy is, and I can tab through these. As you can see, we've got all signed, so local and remote. Bypass is actually something that says, hey, look, I don't care what it's set to, just bypass the policy. For example, if I call a script, when I execute, I can actually say bypass. Just do the default. I want just remote signed, restricted, etc. But remote signed is actually good for what we want, so I can leave that alone. But we're going to need to at least have it as remote signed so we can run our own local scripts that we're going to create. So what is a script? It says create our first script. And all I really have to do here is create a text file that has a PS1 extension. So it could just say write output hello world. Or maybe I could be a bit more sophisticated and write output hello to the environment's username. So if I was to jump over to our environment, I could just create a new file. Now I don't have to use VS Code. I could use Notepad just as easily here. But from here, I could say, let's just close this down. So imagine I wasn't working in a project or a folder. I'm just going to say, okay, well, I want to create a new file. And I want to save it. So I'll save as, we can just say here, sure, we'll put it to root of our documents. And I'm going to save it as hello world. And you'll notice it's already saying, hey, look, PowerShell extensions PS1, PSM1, PSD1, etc. So I'm just going to say PS1 and save. And if I go and look at my file system, there's hello world.ps1. Now within there, we can just start writing our code. So I'm saying, well, we're going to do write output, hello world. And I'm going to save that. Now I need to execute it. Now, if I went to my terminal and I go to my documents, well, there's my file, hello world. So I'm just going to run hello world.ps1 and didn't work. So it's saying the term hello world.ps1 is not recognized as the name of a commandlet, function, script file, or operable program. Check the spelling of the name, or if a path was included, and check it's correct. Well, that's weird. Why won't it run? What about if I try double clicking on it? Nope, it's just editing it again. And this is deliberate. This was a design decision by the PowerShell team, and it's a great one. In the days of BAT files and VBS, I could just execute the name. I could just double click it. And that actually could open us up to problems. If someone put a VBS file in an email, I love you. Oh, well, I want people to tell me I love you. I click it and it executes and it destroyed my system. Bad guys would place BAT files and VBS files on file systems that were the name of a common command. So instead of running your normal command, dir, well, it would go and run this script. With PowerShell, I have to actually tell it I want to run the script. So I can't just double click on it. It's not going to run. To execute, I have to give it the full path. Now, if it's local, well, I can just say // hello world. And then it's going to execute. So that's how I run a script. Again, this isn't, oh, this was a mistake. Why can't I just run it? It's deliberate to help protect me. Now I can also pass the full path. So if I did C, users, John, documents, hello, that's going to work as well. I'm making a definitive choice. That's the file I want to run. But I can't just accidentally run a file that's in my local folder. I have to do the /. So that's our first script. Hello world, and that's all it needs to be. I mean, that's our world. That's how we think about, hey, we are now a programmer. If you can write something that says hello world, that's kind of as good as it gets. Just kidding. So we've talked about to execute. I can do the // script. I could even launch it from command.exe. So if I'm in a command session and I want to run a PowerShell script, well, I can call Windows PowerShell. I can just run PowerShell and then the ampersand, the execution operator, and then the script. Or I can run pwsh-command, again, the execution operator, and then the name of the script. So that's how I can actually run things both locally, and I can run things from another environment, such as a CMD, or call it from something else. Now the next topic can be controversial. You've seen me do write output all over the place. There's also something called write host. When I do write out, I'm sending out to the pipeline. There are various other things that I can target. Now, they are not equal at all. write out and write host are doing two very different things. But they do initially appear to be doing the same thing. If I was to jump over to my environment, I'll close down my epic script over there. If I clears this, if I do write output, hello world, yeah, that works. I could change this to write output hello, and I could say, what do we do that? Env username. Well, that's okay. Well, that output it in that format. What if I do write host? Okay, well that did it a completely different way. So there's other things going on. It did output now host all on one line, write output, put it on separate lines. So they did behave a little bit differently. But if I was doing just a very simple command, just hello world, well, they look the same. So what is the difference between these two things? And the fact that the write host was all on one line might give you an idea of the difference. The goal of PowerShell is to support the ability to pass data down the pipeline, which is the PowerShell object flow engine. That is what gives us the power of the pipeline. And write out is fully supporting that. The output of write out is absolutely going down to the PowerShell object flow engine. It's going down the pipeline to other commandlets further down the chain. Write host does not. Write host just sends the data to the screen, not along the pipeline. Which means if I'm doing write host, I can't capture that into anything else. If it was running with no user at the terminal, well, I might lose it. It might not go to a log file, for example. So we always want to use write output. Its output continues down the pipeline. Write host actually will limit the handling of the data available to us. So really big differences. They're behaving in completely different ways. And this picture can kind of show this. The idea that we have this object flow engine. I start, there's a commandlet, it outputs some data, it goes to the engine can feed it to the next commandlet in the pipeline, and so on. As soon as I did write host, well, it would break that flow. We can kind of showcase this. So let's jump over for a second. And we can do a little test. So if I go over to a window, and let's open up our project so we can see our code. And we'll open up our sample file, and we'll go to region 4. And we're going to quickly create a function. So a function is just a piece of code that I can call from elsewhere in my script. And we want to use proper naming. So I'm going to use the approved verbs. So receive. And I'm going to say receive output. So I'm going to make this up. And I'm just going to say process write host foreground color green. So I've created a function and I can execute that piece of code. So now let's do write output. This is a test and I'm going to send it to receive output. And look, there it is. There's my text in green. So write output had the text and it sent it down the pipeline so it could be processed by receive output. Let's change that to write host. So if I do write host, well, it wrote this is a test, but it's not in green, which means it just went to the screen. It never went to that function. The same way as if I just did write output, this is a test, and didn't send it anywhere. So this really demonstrates the fact that, well, if I use write host, I'm completely bypassing the pipeline. So I'm losing all of that great capability. So the moral of this story is, don't use it. You should be using write output. In fact, I've heard people say, I think it was Don Jones maybe said, every time you use write host, a puppy dies. I don't know if it's that extreme, but certainly the idea is you don't really want to be using it. So why do we even have it? So it can do some pretty output formatting that I can't do with write output completely. So here's some of the things I could do with write host. And that's what I would get. Now, the point of this is, yes, I can do some pretty formatting, but there are other ways to convey things to users without having to do these custom color schemes. For example, I could think about, let's have a look. So if I was to say, instead of write output, I could say write warning, danger, and it does it in yellow. I could say write error, and I get the blood red, the problem. So there are other ways for me to convey different stages, draw different levels of attention to things without having to use write host. So I think the write warning can be a really good one there. Additionally, sometimes you'll see single quote and sometimes you'll see double quote. And the difference is pretty minimal. Generally, we're going to use single quotes. However, if I have a variable, well, in a double quote, it will actually get replaced with the value. This will not happen in a single quote. I can also do certain types of delimiting within a string. I can also use escape characters when I use double quotes. So if we jump back over, we can showcase some of this. So let's go down and look at our pieces of code. So I could create a variable called John. We'll define that. And I can say, in double quotes, and it's going to say, hello, John. Now, if I did that same piece of code in single quotes, it does not expand the variable. I just get hello $name. If I try to do a query in double quotes, what I have to do here, notice that I can have single quotes in it as well. Whereas if I did it in single quotes, it would start terminating the string. So that's where I can actually use a nice combination of these. If I actually then look at query, I can see it kept it exactly how I need it to be. With write output, I can do escape T. So this is going to do a tab. So if I run that command, I get this big gap because I'm actually using those escape characters, the little tick sign. So there are some differences with what I can do between single and double quotes. Biggest one, often for us, will be the expansion of those variables. Now, I can prompt the user for information. I can use read host as an easy way to get input. I can even get secure values by adding the dash as secure string to avoid actually displaying what I type in. Here's an example of doing that. My caution would be try and avoid using read host. The challenge is it makes it interactive. I now would not be able to run this script in an unattended fashion, i.e. no one at the console. I couldn't schedule it to run at a certain time of night. I couldn't run it from a runbook engine. So we want to try and avoid this if we can. Ideally, if there's things you need to know, let me be able to pass it to my script as a parameter. But depending on what you're trying to do, I can absolutely do this. So if I was to jump over to our little piece of sample code, I could run this. Hey, look, who are you? And I go and type in, well, I'm John. What's your password as a secure string? So if I run that, what's my password? Oh, There we go. So it's not showing me what I'm typing. And just for your own kind of knowledge, this command here will give me the value of that secure string. So if I run this, well, there's my top secret password, along with 10% of the world's population. So that's some ways I can go ahead and get kind of user input. So let's look at actually creating our script with input. So here we're going to accept a parameter of type string. We're going to save what's sent to us in $computer name, and I'm setting a default value. And then what I'm going to do is I'm just going to do get WMI object, the class of Win32 computer system for this particular computer name, and list out the number of processes and the amount of total physical memory. So let's actually go and look at this script. So it's in our samples. So if I actually close down the sample one and open up our view, if we go to assets in the file, it's mod4 script 1. And here it is. So there's a parameter, computer name. There's a few different things going on here. Now you might notice this little tick character, which we've used as the escape character. It's also line continuation. Now I absolutely could have just put this on the previous line. But one of the challenges with the pipeline can be it can just get really long. I've just got like a really long command. And for readability, I want to separate it. So what the character does, the little tick, is it lets me just carry on the command to the next line. So if I didn't have that, it would just look like that instead. It's really just about the formatting, how I can lay it out in my script. It's not changing the actual code itself. Now, I could absolutely now just run this. Although what's interesting is that I can't actually just necessarily run this in PowerShell Core. Now, things have been changing with new versions, but get WMI object was kind of an old commandlet. So if I go in my PowerShell Core, if I do, it clears this, something strange has happened. If I do get WMI object, it's not completing it. Let's see what happens if I run it. So it's not recognized. So get WMI object is not available in PowerShell Core. So to actually test this script, I'd have to run it just in regular PowerShell. So if I was to actually open up, here if I do Control-Shift-T, I can open up a Windows PowerShell terminal. If I go to my Assets folder, here I can run my mod4 script 1. I don't have to pass it a parameter, I can just run it on its own. And there, it ran it against that particular machine. I could pass it a machine name. I'll pass it a different machine. So that ran it against that different computer. That one doesn't exist, I don't think, so that should actually error. Now I don't have any error handling in this right now, so it's just going to do whatever the standard is. I can add that later on. The actual machine lives over there. But you can actually see how it's now running those commands against what I'm passing to it. So that's actually a script where rather than prompting me for the input, it's actually going ahead and I can pass it as part of the execution of the script. So now we have parameters. And that one wasn't available either. I had a default value, but I don't have to do that. My other approach would be, let's make it mandatory. And I don't need to do any special code. I can simply say, hey, look, the parameter, well, mandatory is true. So if we now jump over to our script, and I'm actually going to switch over. I don't want to run in Windows PowerShell. So here I've got this. I'm going to kill this one off because I don't have to use get WMI object. You'll actually see I've got a mod 4 script 1 sim. This is the PowerShell core, and this works in Windows PowerShell as well. Git sim instance behaves exactly the same way. So just to demonstrate this without changing anything, if I run this, it's going to work on PowerShell core. Likewise, I can go ahead and pass it a name. But in this case, well, I don't want this default value. I'm going to change this. So remove a default. And this time, my parameter, mandatory, equals true. And I'll save that. So now if I run it again, no problem. If I don't pass it a name, it's going to prompt me. Oh, okay. Well, I guess I'll give you a machine then. And it works. So it's really that simple. That's how I can switch between, hey, having a default. I'm just going to roll that back. Or actually making them enter something. And if they don't enter it, well, I can go ahead and just prompt them. And we've now switched to the kind of modern approach. So instead of WMI object, I'm going to get a sim instance. I can have multiple inputs. Here, I've changed it to an array. So instead of it just being a string, you'll see it's a string with a set of square brackets which represents an array. So I could pass one machine, I could pass 5 machines. And so what I'm doing here, computers will contain possibly an array, it may just have one. And so I'm going to iterate through them. So what I'm saying is, look, for each, I'm giving it an object. So for each computer name in computers, I can call this anything I want. The name I put in here is how I can reference each object in turn. So one at a time, each member of the array stored in computers will be put into computer name and then run the piece of code. Then it will go to the next one and so on and so on. So it lets me actually do whatever I want for all of the different members of an array. And I'm actually going to build on this. So here's a bit more of an advanced script. And I'm actually just going to jump over. So if we go to our project and we go to our mod 4 script 2, here's that code. So it's exactly as I just talked about. I have mandatory parameters. I have an array of strings this time. I'm going to store in computers. And then for each computer name in computers. So what this is saying is computers is one or more strings, one or more objects. And I can put anything I want in here. I'm calling it computer name. So one at a time, each element of that array will be copied into computer name and then run this block of code. So I'm getting the sim instances for computer system and operating system. Then I'm creating a hash table. So a hash table is really just property names and values. So property name called computer name, and I'm setting it to $computer name, which is the string that I got from the array computers. I'm going to set a property name called memory to coming out of the computer system WMI of the total physical memory. And so I'm going to create this hash table and then store it as a custom object. I'm going to store that custom object in out object and then write output out object, which in this case will go to the screen, but I'm actually sending it down the pipeline, remember. So if I was to run this mod 4 script, I could say, okay, I'll send it one name. And it outputs that detail. I could send it two names. I can send it 3, 4, you get the idea. And what's great is, remember, I'm creating this object. And what it's outputting to me is deciding how best to output it. So it's doing format list. But I could change that. I could say, well, no, let's do it as a table. That's exactly what it can do because I'm outputting as a custom object. It's an object that then reaches the end of the pipeline, so it decides how best to display it. And I can try and walk you through this. So I'm going to, rather than running the script, I'm going to jump inside this for each. Now I could use debugging here in VS Code as we talked about before and look at the various values. But in this case, I'm just going to kind of fake it. I'm going to say computer name equals SAP Azure US South Central DCO1. So now I could run this line to get the computer system information. This line to get the operating system information. I'm just pushing F8, remember. So if I was to look at this point of Win32 CS out, well, it has a whole bunch of properties. And so if I pick one of these properties, for example, total physical memory, that's that value for that machine. And that's what I'm then storing as part of my hash table. And so if I run this block of code and then go ahead and look at my param out, it's those names and values. And if I look at what it is, well, what it is a hash table. I'm setting it to get member. My next line, okay, well, let's take this and create a new object of type PS object. The properties are all defined in this hash table. I'm going to store that in out object. So if I now look at out object, well, there's those values. And if I look at the get member, well, it's a custom object. And I'm just sending it down the pipeline. So that's our first script. Our first script is really doing something, a bit of meat around it. Hey, I'm getting information about remote machines, and we could obviously build on this. We could do many, many other things here. So in our next module, we're going to dive into the more advanced scripting techniques. Remember, I'm updating the GitHub repository for this as we go through. I'm adding the videos. So if I refresh here, I think there's now 4. This will be number 5. So watch them in order. If I refresh the project, you can see I'm actually constantly making changes, but it's got all of the code in the assets folder. We have all of these scripts we're doing and everything else. So everything you need is in this repository. So you can trial this stuff out. So you don't have to type it all in. You can just go and use this. Again, if you don't have this, here's the instructions on how to get this. You have to install Git first. So that's this link. Install that on your machine. And then open up a new command prompt or PowerShell. You need to open it up after you've installed Git, so it's as part of your path. Then just run this command. So I'm creating a folder called PowerShell MC, and all of this will be available on your machine. Hope this was useful. Go create some little simple scripts, and I'll see you at the next module. Thank you.